Hi everyone, happy Monday. We have just a little bit more than 1 week to go, and then we are done with this semester. Okay, we are going to enter a new topic today, which is unsupervised. We have to uh, we have been doing the supervised for a long time, and most of the time, we are doing classifications. We are trying to predict the labels, right? So that is called classification. And if we have a real value to predict, for example, like if we have a data set of the house prices, and if we have a new sample, a new house will be put to the market, and then we can estimate the value of this new house, and then this is a prediction, because for a prediction we are predicting a real number, not a class label, right? So no matter we are doing classification or prediction, the common part is we are dealing with we are predicting some of the values based on a ground truth. And in other words, when we are doing the supervised machine learning, the ground truth is available no matter they are the class labels or the real values like the house prices. The ground truth is available. However, if we move on to the unsupervised, so we don't have the ground truth. Okay, so you may ask, if we don't have the ground truth, what can we do? And I think you are right. And without the ground truth, and we are not able to do a lot of the cool things, but still we are able to do something. And one of the common tasks is we can put the samples into a few clusters, and inside of the cluster all the samples are kind of close to each other, and between the clusters and the samples are away from each other, and then we can identify some of the clusters in the dataset, or we can do clustering. And another thing is, we can find the correlations. And one of the most common thing is the beer and diapers. So it was a long time ago that some people analyze the people's purchase history of a grocery store, and they find that the people who buy the customers who buy beers are also likely to buy diapers. And the reason is, at that time probably there are a lot of the husbands, they stay at home with their little babies, and they get really bored, so they buy when they buy diapers, they also want to buy some beers to treat themselves. So that is called correlation mining. And the third thing is, we can try to compress the data a little bit. And for example, we can do the PCA, and you can only keep a few the most significant features, so you can reduce the dimension of the dataset. Okay, so those are all the things we are able to do without the ground truth. So in other words, those are all the things we can do in the basket of the unsupervised machine learning. And today we are going to do the first part, which is a clustering, and we are going to see a very common uh, clustering algorithm called K-means. In the K-means, there are three important concepts. So the first thing is cluster. So a cluster is just a group of the records in which are similar to each other. And when we are saying k-means, and the means or the mean of a cluster means that uh, the center of a cluster. So what you can do is, if you say you have 10 samples and they all belong to the same cluster, and then you just take the average of all the features, and then you got the mean of the cluster. Since we know what is the mean, and then what is the k, so the k is similar to the k in the k nearest neighbor, so that is a number we have to specify. And in the k nearest neighbor, and that is, the k means how many closest neighbors we are going to check before we decide the label of the class of the sample to predict. And then in k means, and the k means how many clusters we are going to try to cluster the samples. Okay, so in the K-means, there are really a lot of the different versions of this algorithm, and I'm showing you the most common one. So the first step, you need to pick. Well, you will be given a K value. That's the first step. Okay, and then you want to pick randomly K points and as the cluster centers, or we may say they are centroids. Okay, so you just randomly pick K samples as a centroid. In the next part, you want to assign each of the sample to the nearest cluster centroid. Okay, so for each of the sample, they will be assigned to the nearest cluster centroid, and after that, you can just take the average of all the samples inside a cluster to adjust the centroids. So you're after then the centroids might be a different value, or a value which is kind of very far away from the original centroids. And after that, you want to repeat it as a step 2 and the step 3, and eventually you want to stop when you do 2 rounds, and then the clustering result doesn't change at all. So the step 2 and 3, those 2 steps will be the iterative steps. So this is the example. We have 3 clusters, and you can pretty much see, and then we say we want to cluster those samples into 3 clusters. So we randomly pick 3 centroids, and then we are using the diamonds. So 1 diamond here, and diamond here, right? So you may say, we are not so lucky in picking the centroids, but it doesn't matter. So in the first round, after picking the random centroids, and then we are going to assign all the samples to the nearest centroid. So we have a red cluster, a blue cluster. But if you see the blue cluster, you may say, okay, this area is a good cluster, and this area is a good cluster. But however, the blue centroid takes part of this cluster on the top, so it is not right. And then consider the next round. So in the next round, we are going to do this part again. So we are going to calculate the means of the samples inside each of the cluster. So for all the samples in the blue cluster, we are going to recalculate the centroids. So let's assume that up here we have 50 samples, and down here we have 20 samples. Okay, so if we want to recalculate the location of the centroids and what is going to happen on the blue centroid, so you will see something like this. So since the majority of the blue cluster is up here, so they will drag the centroid up a little bit, right? And then after that, after we have recalculated the location of the centroids, and then we have to reassign all the samples to the nearest centroid. So in the next round, we will see, okay, so all the the green centroid will go up a little bit, and then the blue centroid will go up a little bit. So eventually, after doing this for a few more rounds, and then it will stay stable, or we can say it will converge. And then when we find the clustering results is stabilized, and then we can stop this process. And then the final 3 centroids will be the center of the final clusters. Okay, so this is roughly the idea of doing the K-means. And when we are doing the K-means, our goal is we want to minimize the sum of the squared distances, or we can say that is the within cluster squared sum squares. So when we are trying, remember when we describe this algorithm and we talk about the distances, right? So we are going to assign each of the sample to the nearest centroid. So we are talking about the distances. And when we are doing the distances, then remember we have to do the normalizations. And otherwise, if you have two features and the range of them are different, and then the feature with the larger range will dominate the distance. So remember, for the k-means, we do have to do the normalization. Okay, so I will see you in the next video, and we are going to see some of the code examples of the k-means.